Let me do the same things you guys did, right? So cd app home server start geode. So if you guys want, you can also check what's the script actually doing. I mean, it's fairly simple. Let it run first. So first step, right? It's a starting allocator.
Real quick for all the Windows guys, just put git bin in path. That should work.
So sorry, can you say?
Add git bin directly to your path environment variable, and that should fix the vagrant SSH.
Oh yeah. So if you guys are having vagrant SSH problem in Windows, there is a workaround to add what? Sorry.
Add the git binary directory, bin directory.
Okay.
To your environment system path.
So that fixes it. But I guess the problem is still with the zip, right? So we're starting a locator. Then we connect to the locator. We set some configurations there. Then we start a server. And then we create a few regions. So let me walk you guys through all the steps here. So this is the exact command we are running, right? Oh, wait a minute. Yep. So start a locator, pass the name of the locator, and then we are specifying a few ports for the REST API. Then we configure PDX, which is the internal serialization used inside Geode. We're not going to worry about that now. Then we are starting a server and saying that this locator here running on localhost, that's our locator for this system. And then we are enabling the REST API with this flag and saying that the REST API is listening on this port. We are deploying a jar, which could be pretty much any Java code. In this particular case, that's what we use for the Spark connector. So this jar is what's enabling Spark connector in Gemfire. But it could be like any Java function that you guys have that you may just want to run it inside the cluster, right? Distribute the execution or play with the data inside Geode, right? And then we start creating the regions, which is, as you say, create region, the name of the region, and then the type. As we said, as I said before, you have couple types: partition, replicated, partition persistent, partition redundant. I mean, depending on what you want the data, right? Create a couple of them. And here we are importing some data. Just so we have collected some data, so you can kind of play a little bit with that while running locally, right? And then we run a command named describe, which just tells you what you have in the region and what type the region is. So now the next part of the lab would be to play with gfish. So you can all type gfish. Is it good for you guys to read this font size? Do you want me to increase? OK. So gfish is the command line interface for Geode and Gemfire. So since I'm using localhost, I can just type connect. And now, if I just hit tab, and let's do a yes, these are all the commands available for you. It has auto-completion. So for example, the first command I'm going to do is list, then hit tab. And you can say, I want to list the members. Or I want to list the regions. Or I want to list the clients. I don't have any client right now. I deploy the jar. I can list deploy jars. So here is where you can, like, while you are developing, you can interact with the cluster. And also you can use this to manage the cluster, like if you want to do something in production or something like as well. So let's say I want to create a region, right? Create region, name, test, tab. Here are all the options for the region. So I want to specify the type. Remember that you had all those types. Tab, all the types appear. And let's say I want a partition. Oops.
No. The line.
There you go, redundant. And you have all the options, right? So we have all the regions created already. You can execute queries as well. So queries here, they look like SQL, but they are actually OQL, which is a standard way for querying objects, right? It's a language, it's a formal language. You can look on Wikipedia, named Object Query Language. The only difference here is instead of using like from and region name or table name, you just do a slash and then the actual region name. So let me list the regions again. Query, select star, oops.
Não, faltou igual.
From, probe,
Underline. No.
requests with that's 0.
Ah, eles são simulator. Não é coisa. Você não importou os dados.
Device.
Não tem. Não está importado. Ah, simulator. Falta L.
Simulation. Here are some of the data we already collected. You can query from the command line interface. So this is a very quick intro to gfish. Now, as an extra step or an extra part of the demo, I'm going to stop Geode. And inside the VMs, we already downloaded the Docker images, right? So I'm going just to say that for the sake of demo, you can run everything on Docker as well. The Docker images are here. I'm going to just start gfish inside Docker for you. So nothing is running on Docker right now. Here's the command. So this is also available on the GitHub if you want to copy that. In this case, if you are familiar with Docker, right, I'm just running an iterative shell. So I can run gfish here the same way I was running before. I can start command, start server, start locator, and do everything. But if you're going to play with Docker and fire a Docker instance to be running on the background, then you can just, of course, remove the IT and do a -d, for example, right? I'm not going to cover Docker in details here, but we also have a Docker slides available on our SlideShare. And I can talk about that later if you want to. OK. Let me start Geode back. And any questions so far?
Is this documentation available somewhere?
Sorry?
Is that documentation available somewhere? It's in the Wi-Fi folder.
Yeah. We have a lot, all the READMEs, including like setting up Raspberry Pi, setting up every step. They are already part of the VM inside the Wi-Fi Analytics IoT. Going just to show one more thing with. Sure. OK. Sorry, yeah, I was going to expand. So the HTML file is not yet on the Wi-Fi directory you guys have. So this is going to be there. You can just do a git pull, but the network is horrible, so I wouldn't do that right now. But later, I mean, we are going to, of course, share all this, and you can grab the HTML, like the steps by steps there. So we also have the ASCII docs available there with all the steps. So there was one guy that was running the Docker command. Are you good? The Docker?
Well, I entered it and it opened the GS.
GFish, yes.
Yeah.
But when I navigated to that URL, it didn't load.
Oh, the URL?
Yeah.
No. The URL is another thing.
Oh, okay.
Sorry. That's why I was saying that this step is actually optional. Sorry about that. Yeah, it's just optional. So are you guys with Geode up? OK, great. So for those that are with the Geode up, just access this URL here on your host browser. So 192.168.
Yep.
Is the URL working for you guys? Yeah. I'm sorry, I think I missed the port. Sorry, it's 888. Sorry, man. There you go. Yay. OK, so it's still written Gemfire there, but it's actually Geode. So we are incubating, so we are still doing some cleanup. So with the REST API, this is Swagger. I'm not sure if you're familiar with this. This is like a standard REST interface, so you can like browse REST endpoints and discover which operations are available and like play with them and execute using a browser, right? So for example, that same query, right, that we had before, you can execute like on any of these endpoints, right? Or we have region operations as well. So for example, if I click here, oops, it should, where is my list region? List region here. Try it out. Response body. Oops. So here you have all the regions available in the system. What I was going to do is actually just to execute this on the browser. So using the REST API, you can pretty much do everything. You can put data, read data, execute queries, call functions. You can also do some filtering within the region. For example, you just want the keys or you just want the data. You can also do some monitoring and management as well, because, for example, you can list the members and you can also like ping the nodes to check if they are alive or not. Feel free to just play with the interface. For example, for all endpoints, you have this try it out that you can just click and it's going to execute for you. And as you can see, the nice thing also about this Swagger interface is that it also serves as a documentation, because you can see that, for example, if everything works, this is the HTTP status you're going to receive. If it fails, that's the status you're going to receive. So you can kind of use that also to catch errors in your application. So this REST API we showed here, that's the same API the Pis are using to post data on Fred's laptop. That's the exact API, right? Next, so for the quick intro on Geode, that's what we had. And now Fred's going to talk about Spring XT. After that, we have a break, and then we get back and do the Spring XD lab.
So as we now know at least how to start Gemfire Geode, how to start the locator, how to start a server, how regions are created, how regions can be queried. You can actually do the API. There's JFish. You can do RESTful requests as well. Post data, get data, query, etc. You can actually start servers in parallel, so it scales out. And then as start server, they join the cluster, redistributes the data automatically, et cetera, et cetera. So it's suitable for, it has very low latency, so you have a lot of data coming. You can actually just persist the data and query data and get events on your clients. The way we're going to actually get the data there is creating those data pipelines that we mentioned. And Spring XD, it's actually the solution that we're going to use to create those data pipelines. And there are usually a lot of questions regarding Spring XD and how it compares to Spark Streaming, as I already asked. How do this, how we do that, can we change this, can we do that? And we will actually touch it a lot right after the break. We're supposed to do a break now. So we're going to do that right after the break. But I'll give you just a quick intro on basically how it is. So you can actually run multiple nodes of Spring XD. And we actually will start different containers and join them as a cluster. As this case, we're going to just run inside a VM. We just start what we call a single node server. But we can actually have multiple, of course. And we'll have something called the Spring Shell that we're going to use actually to connect to the containers and create, remove, update streams, et cetera, et cetera, et cetera. It uses Zookeeper to actually manage the cluster. And basically, all the communication, it's REST over HTTP as well. The way it works, it basically mimics the Linux process in a way that you could, if you create a stream, you likely have steps, and you declare those steps exactly how you build Linux commands with pipes. So you can actually have, my stream is going to be, let's say, listen to this HTTP port. Whatever comes from there, I'm going to do some parsing. Then I can do some transformation as well. And then let's say I'm going to send this information to Geode. What I'm going to do is the stream is going to be HTTP port. Then we're going to do a pipe. So whatever comes out of this, we're going to basically do a filtering, for example. Whatever comes back for filtering, we're going to do a transformation. And then we can, do, for example, do another pipe and send this information to Geode. And then he asked, for example, can we do that with Postgres? Yes, so we can actually have one of the outputs. It's basically JDBC, for example. So instead of sending to Geode, we can send to a JDBC database. But of course, then we need to convert that to SQL before, to relational. Or we can actually send that, for example, to Splunk, to Kafka, MQTT to connect directly to devices in different protocol. So basically, it's an aggregation of what we call sources. There where the data comes from. Transformations. How does it compare with Spark? Well, Spark can actually be a transformation. We can actually use a Spark process to distributely process the data we capture in Spring XD. And then we can, in this case, for example, our first transformation, that's calculation of distance, was a Groovy script. So there's actually a Groovy script here as a transformation. And this is actually only a few of those connector availables. There are dozens and dozens of connectors availables. This is based on two very long-term projects. One's called Spring Batch, and the other one's called Spring Integration. So any connector available to Spring Integration, and we have hundreds of those open source available freely on the internet, you can actually add as a source destination or a processor here. It's really, really simple. If you can, let's say, if you want really to apply some kind of deep learning analytics as part of this, I can just, for example, do a processor here and then trigger our process, a Python process, or whatever you want. The only thing that needs the requirement here is basically your process needs to read for standard in and output to standard out. So actually, Spring XD will connect it here. It's really, really simple. We're going to start right after the break. we're basically creating very simple streams. So let's start with basically just a time tick, for example, as a source. No transformation, then the destination is going to be the console. As we deploy, you're going to see it outputting the time to the console. Then we're going to destroy it, for example, and say, well, instead of this, let's, I don't know, get that time and do some transformation or do a filtering and only get it for when the even numbers or something. Then you can actually call something else, and we will build it up until a point we get a source that is HTTP, so we can post stuff to see it to the console. Then we're going to remove it and say, now source, we're going to send to Geode and apply this transformation. That's actually the flow we want. The other really cool thing about Spring XD, of course, you can deploy multiple streams. They're going to manage it all. If one of the servers is down, it redeploys your module to other servers. You can distribute it through all the servers. You can actually have one of the module, let's say source running on a machine, the destination other, or I can have them all split through all the machines, so you can configure the deployment on the way you wish. And then it scales horizontally, scaling out as well. You don't need to redeploy anything if you add a new server or something. It does that for you automatically. It distributes that automatically as well. Cool?